Okay, welcome everybody to the SRA webinar series. We're excited for our SRA, Society for Risk Analysis annual meeting that begins this weekend in New Orleans. It's not too late to come if you want to come to the meeting. Just go to sra.org and you can click on a microsite that we have set up there that is really fantastic with information and hotel and travel options. So we're recording this webinar, as we do with all of them. You may go to sra.org and find them there. We have quite a catalog, quite a collection of webinars, all freely available to members. So please think about joining if you haven't. And if you are a member, go there and check out some of the great videos. For today's webinar, if you have questions, please submit them through your GoToWebinar control panel. Just type them into the questions box, and I'll read them to Dr. Wren as we get to them. Some of them we'll answer during, and some we'll answer at the end of the webinar. So today's webinar is Systemic Risk, Challenges for Public Discourse and Policymaking. Our presenter is Ortwin Wren. You can see him here. He is Scientific Director at the International Institute for Advanced Sustainability Studies, IASS, in Potsdam, Germany, and Professor for Environmental Sociology and Technology Assessment at the University of Stuttgart. He also directs the nonprofit company Dialogic, a research institute for the investigation of communication and participation processes. So with that, Ortwin, I'm going to turn it over to you.
Well, thank you very much, Brett. I'm really delighted to be tonight the presenter for the webinar, and I look forward also to all the questions that you might have, and I'm welcoming all kind of comments and questions. I would like to wait until the end of my presentation to give you my responses so that we don't have too much of a fragmented talk, but well, you can during the talk, and then I will address them later on. The topic that I would like to address tonight is the topic of systemic risks. And that's a fairly new term. It derives basically from the financial system, where systemic risks have been used to describe the crash of 2008. But also the term has been used by the OECD much earlier in 2003 to describe threats to very vital infrastructures or critical infrastructures. But over the years now, I think the term systemic risk has gained some kind of more specific meaning. And in my definition, a systemic risk is a risk that threatens the functionality of a system that provides vital service to society. So basically, we're talking about a system that provides something that people really need. It could be energy, it could be water, it could be security. So something that they value and that is essential for the functionality of society, either economically, socially, or culturally. And so it's important to see that there are different domains for systemic risk. We're not just talking about health risk. We can also talk about technological risk. We can talk also about natural risk and natural hazards, and we can talk about social risks or cultural risks. And there are some common properties that we believe can be good descriptors for systemic risk. The first one is that systemic risks tend to be transboundary. They don't have to be global, like, for example, global climate change or cybersecurity, to typical systemic risks, but they should be at least transboundary so that they go beyond the normal regulatory framework, which is either national or regional. And as soon as, of course, we have transboundary effects, it's much more difficult to govern and regulate these risks. And we'll come back to that later. The second major characteristic is that they are complex and interconnected. Now, the word complexity is something that is also very fashionable these days. And when we talk about complexity, we mean that between causes and effects, there are many intervening variables that either attenuate or promote the causal connection between the trigger and the consequence. It means that we have a very differentiated systems of moderators, of promoters, of attenuators with a lot of feedback loops. And if something is very complex, it could be that very small changes within the system can have a major outcome in the consequences that that system may produce in a hazardous situation. So important is that it's not easy to grab what is basically the cause and what is the effect, and that between cause and effect, we have a whole set of intervening variables that makes it difficult, sometimes even impossible, to find the right and the correct causal connections. The third major element here is that these risks tend to be stochastic. Now, all risks, of course, are expressed in probabilities, but when we talk about probabilities here in a stochastic system, we believe that a cause doesn't have a deterministic consequence, but that if you have an identical cause, it could have a whole array of consequences, but they're not arbitrary. So it could be A, B, or C, but it cannot be D, F, or Z. And we can very often even attribute probabilities to the distribution of A, B, C as a function of a trigger Z, for example. This kind of stochastic relationship is important later on also when we talk about governance, because we cannot be sure that these consequences pop up. We only have probabilities, and they may be smaller or larger than what we would anticipate when we just look at the mean distribution values, or maybe the 59% interval or some other kind of mathematical expression of it. And the last point, which is very much related to this stochasticity and the complexity, is that systemic risks, the dose response or the cause-effect relationship, often also with tipping points or tipping spaces in which major changes happen within very small changes of the trigger value. And you can, probably familiar with such tipping points in ecological systems. A lake can break down and, with a lot of nutrients coming in, and then at a specific place and time, it turns into a dead lake. And then it's very difficult to reverse that again. And there are a lot of things that we're worried about in terms of climate change, for example, or in terms of a lot of environmental issues, that something is not showing up in terms of a detriment until a specific threshold passed, the whole system breaks down, and then it's almost impossible to repair it again, or it would take extreme long time or many, many resources. Those are the four major elements of systemic risk. I repeat them again. They're first transboundary. Secondly, are complex and highly interconnected or tightly coupled, in the words of Charles Perrow. Thirdly, they're stochastic in the cause-effect relationship. And fourth, they're nonlinear with tipping points in a way that the scenario expresses itself of the potential damage that can happen. Now, why do we put a special name for this? One thing is that societies have been extremely successful with reducing conventional risk. And conventional risks are those risks that are usually not very complex, fairly linear. You know the cause, you know the effect. They are within national boundaries. They may be stochastic, but then we have a very good probability distribution over outcome, and they tend not to be nonlinear, or they can be a logistical function, but at least you can say that, the more you do in terms of creating a higher risk, the more you get a bad message back home, so that you can learn in a sense from the errors that you produce. One of the things that is quite interesting in terms of risk management and risk governance, we have been, at least in the OECD countries, extremely successful with reducing conventional risks. Let me give you two examples from Germany, and I could also take examples from all OECD countries. It's a little different in non-OECD countries. We had 1960 in Germany around 5,000 fatal accidents at work. So occupational health and safety was a big issue. And now, 30 years later, 50 years later, we have only 370, and we have more workers because East Germany was reunited with West Germany. We have so a total larger number of people working, but in a year it's just 375 with a working population of around 40 million. That's a fantastic number in a sense. I mean, for the 340, it's still not a fantastic number. That's very clear, and I don't want to sound cynical, but going from 5,000 to 300 is certainly a success. And we can do the same thing for car accidents. We had 1972 in Germany, something like 22 to 23,000 fatal accidents in Germany. Now we're down to 3,500, and we drive more. So to that extent, again, it's a very success story. And if you go to technical accidents, accidents at home, all of that has been really reduced over time, so life expectancy has increased. So all the traditional instruments that we have in terms of dealing with these conventional risks is basically standard setting, good monitoring, using precaution if we have some uncertainty about what it might affect our health or ecological systems. So that is fairly a success story. We can do always more to it, and it's not taken for granted. But of course, if you go outside of OECD countries, it's very different, because there, these conventional risks still kill most of the people in most of the developing countries. Now, going back to systemic risks, is that we believe, and that's part of, I think, our challenge, that because of these new interesting characteristics, we probably have a much more a problem of dealing with them in terms of risk management, in terms of risk governance, but also in terms of risk communication. And let me just give you a few reasons for that. The first reason, of course, is, and we can go along the characteristics, if you talk about transboundary risks, we don't have normally institutions that could regulate risks over boundaries. We can say, okay, each country can have its own risk management portfolio, and normally they may also have ways of talking to each other and aligning their risk policies. Nevertheless, it's much more difficult to have something that regulates or manages risk if many nation states are involved. And if you look again at climate change, to get to something like a Paris Agreement, we have a commoner's dilemma that everybody thinks if all the others are doing their share, then I benefit from it and I don't have to pay for it, or the other way around, that people are saying if there is the free rider position available, then I won't join the club. So that's one of the issues that we have, is transboundary risk, and if there's systemic, it's even worse because of the other characteristic, to which I will say a few things. Thirdly, they are stochastic. So stochastic is another issue, because it gives people the possibility to deny risks or their existence. It's quite interesting to see, if you just picture a risk in a purely stochastic way with a normal distribution, the head tape, the function that you're all familiar with. If you are asked to change your behavior because it's risky, you believe you're on the right side of the function, the long tail on the right hand side, saying it won't happen to me. If you want others to do something, you believe you're on the left side of the normal distribution function, and you say better safe than sorry, and if something happens, it will happen to me. So communication between these two sides is extremely difficult, because you cannot say, if you, for example, smoke, which is not a systemic risk, but it's a good example. If you smoke, you're going to get cancer. Well, most people won't get cancer from smoking, but you double your probability that you will get cancer. So people who smoke will also know one person who got 95 years old and has never had any problems but smokes like hell. And others will know somebody who is 30, had never smoked, goes to the gym every day and got a heart attack. And so you can basically focus on the part of the distribution curves that's favorable to your own attitude. And we see this in climate change. I mean, the climate change deniers are people who always fix towards the 5% residual probability that all of that is not anthropogenic. And they say, well, we believe in this 5%. And, you know, you can deny the models, but a lot of people don't deny the models anymore. They deny the significance of 95% or 99 if you take 3 standard deviations. So that's part of stochastic risk, that it makes it difficult also for policymakers, because they always face 2 sets of interest groups, one who believe they will get away with it, and the other ones who believe that even the slightest contamination will kill me. And that's partially what happens, whatever in the glycosol debate, or in, you know, if it's pesticides and herbicides involved, we see those kinds of polarization between A and B, and we can see it also in a lot of political issues. We talk about refugees. I mean, you see it polarizes because, yes, not all refugees are good people. Some of them are really criminals, some of them are terrorists, very few of them. But if you're fixed towards that side of the distribution, you come up with very different policies than if you look at the other side, where you say, well, these are all skillful workers that can help us to improve our national product. And the last one is even more problematic. That's the nonlinearity with tipping points, because humans learn basically by trial and error. And you know this from school. You had a test, and if you failed the test, you started to work. If the test was good, you say, well, you know, I worked enough, so I'm very well prepared for the next one. Our whole economy is based on trial and error. If you start a company and you have a product that nobody wants to buy, golden toilet brushes or whatever, then, well, you get the receipt from the market, and the market will tell you, well, your product doesn't sell. You can go bankrupt and start something new. It's a typical trial and error system. The whole market is a trial and error system. And that works very well if you have a linear system, because linear system tells you if you do more of one thing, you get more bad or good thing in proportion to what you're doing. If you have a nonlinear system with tipping points, you do something, you don't get any negative feedback. Maybe you even get positive feedback, like in the financial crisis, you know, you actually earn a lot of money. And if you hit the tipping point, then suddenly the whole financial system collapses and everybody loses, and even the taxpayer loses, in spite of the fact that the taxpayers, you know, didn't get any basic benefit from the financial lottery beforehand. So if you don't get negative feedback, you don't change your behavior. And I think that all is then accumulated in the one that I missed, it is complexity, because if you have a very complex system, it is counterintuitive. Our understanding of causation, or intuitive understanding, is that something is being caused by something that is close in space and time to the event that I want to explain. If I have a headache, I say, well, what did I eat yesterday, or what did I and the same thing is with some of these complex risks. I mean, it is not obvious and it's very difficult to grasp. If somebody says, well, if you drive a car and you emit CO2, that may have an impact on a flood in Bangladesh. You say, well, my driving here in the United States or in Germany or wherever has an impact on water in Bangladesh. Give me a break. That's just not plausible. And plausibility is a very, as you know, futile way of making judgments, but it is a way that we intuitively judge. And this kind of plausibility is based on proximity in time and space when it comes to causal connection, to vicinity or proximity to everyday experiences, and also to narratives that we're familiar with. And all this kind of very complex issues they're implausible. And that is why it's so difficult also, for example, climate change or some of the others, these very complex issues that people just believe populist because they say, well, this is just too far-fetched. That can't be true, and they come up with simple truth. And unfortunately, they're all wrong, but they're plausible. And to that extent, if you have all these four characteristics together, it's this complex. People don't believe in the causation. If it's transboundary, we don't have the institutions to deal with it. If it's stochastic, we polarize the view between those who are fixed on the right or on the left-hand side of our distribution curve. And if you have a nonlinearity with tipping points, we believe that we always get positive feedback, or at least no negative feedback. Why should we change? And that's a situation with systemic risks. And the interesting thing is that most of the systemic risks that we are talking about, and I'll give you a very few examples. If you take the economic sectors, basically the finance system is certainly one of the major risks there. If you talk to the ecological system, it's probably climate change, one of it, but also sweet water use and its abuse, very big systemic risk. If you go to technological risk, I think cybersecurity is a really important issue. If you go to health, it's pandemics. And if you go to social aspects, it may be the growing inequality between the rich and the poor is, again, something which I believe is a systemic risk. So something that really threatens the functionality of something that we really believe we need to have, and that leads to the satisfaction of vital interests. So the issue is, if those are kind of first difficult to identify, but it's even more difficult to communicate, and it's even more difficult to govern these risks. And if you talk to politicians or to regulators, they say, well, even the transboundary issue in itself is already extremely difficult. But if you don't get any support for this kind of regulation, even if people know it's dangerous, but they don't want to pay for it because there's no negative feedback immediately, something very typically, even for Germany, if you talk about climate change, I mean, Germans are really in favor of more protection of climate change, but if you tell them, well, we should drive less your private car, or gasoline should get more expensive, then they get really rebellious and say, well, that's not what I think it's necessary. So you have this problem that in conventional risk, it was really clear, you save a person directly in front of you. Well, you do everything to do that, even if it's a statistical person, but it's very plausible that that person, let's say in occupational health and risk, is being saved. With climate change and others, it's kind of, it's so distant, and then immediate needs become much more important for you, and then it's very difficult to get policies that are really effective and not just rhetorical. Now, what can we do? And that's my last part. The first thing, of course, is that I believe we have to make the systemic risks more plausible. And plausibility, as I said, is something that gives you a familiarity with that kind of risk, so that you can see, oh, that looks like it could happen, and it's better and be prepared for it rather than just to ignore it. And since with a tipping point, we don't want to wait until the crisis comes and then to say, look, here's a crisis. Now we have to act. Well, with a tipping point, there's a problem because, even with CO2, it takes around 85 to 100 years before it dissipates. And so it's very clear that even if you now acknowledge, oh, we do have a problem, we want to do something, it will take quite a few decades before you get any better. So mitigation certainly would be a much better option than adaptation at this point. So what can you do in terms of making these more plausible? I think One of the things that I think scientists can do and risk analysts can do is to create, in a sense, games or virtual realities in which you can exercise trial and error, really in the error. So if you are in a virtual world and you can say what happens if I don't do anything about climate change, and then go through the years and then see, oh, this is going to happen to me. And so more you're engulfed, the more you're involved in that kind of game or in that kind of environment, the more it seems likely to you that this is going to happen. And I think that's an important way of learning by virtual trial and error rather than by real trial and error. If you cannot afford the error anymore, you have to put it into the virtual world where you can afford it, but it has to be real enough that you don't think that just a game, but that you think, oh, this could be real, at least that, and then we have to do something about it. So one of the things that I believe is very important is that we have very good simulations of these systemic risks, even if you don't know all uncertainties. That's fine, and we can speak these uncertainties, but we could also show what happens, and then we can go through our stochastic curve and say, look, we now is a 95% probability that's going to happen, and that is what it is. Now, if you believe in the remaining 5%, good luck to you. And that, I think, makes it much more tangible for people to understand, what is at stake. And the second point that I think is very important is that we create institutions that are transboundary. That's not as easy as it sounds, but I think the one thing that we need to do is to create taxes that are transboundary taxes. This could be, for example, if you use the commons, and that some of that is being brought back into institutions that use that money for regulating transboundary risks. Because if you just look for cooperation among states, I think we'll look for a long period of time. If you had these transnational institutions that get some money from extra taxes, that could be a really breakthrough. It could be the Tolbin tax, you may be familiar with that on capital, but it could also be if airplanes put up or damage some of the atmosphere with their exhausts, that they pay for using this common space, or your ships using the oceans. And if we had a specific tax for that, maybe we could then use that money, for example, for cleaning up the ocean for microplastics, which is another systemic risk. So in that sense, that is, we need transnational institutions. I believe it will not be sufficient just to have the coalition of the willing, which is what we do right now in climate change, because as soon as somebody is not willing anymore, like in Brazil right now, well, then the whole thing, gets stalled, and we don't, really move forward. If we had institutions that had some extra money to do this, then they had also a continuity, which, because they have their own financing, which I think is extremely important. We could also do it with big foundations, but I think the money that we need to do there would probably be best covered by global taxes. And the last point, which may be one of the most important for me, is that we need new governance structures in which we involve the people who will suffer from this systemic risk in regulating these risks or in governing these risks. And that goes into the area of public participation and public involvement. Since those things are implausible, since it tends to polarize, since it seems to attract populist views, I think we need to make a transition from the regular table in a pub to a round table in a participatory format. And my own experience with these kind of formats is that once you have people in a situation in which they take responsibility for their own environment, they don't listen to populists anymore so often because they want to know it, because they feel responsible for it. And of course, not everyone, but most of them do. But you have to provide the space for these kinds of participatory processes. We can do them mostly on a community level. I mean, that's very clear. But if millions of community come together, we have a swarm intelligence that can actually help to make the changes and the transitions that are necessary. And I think we have still not enough of these kinds of participatory processes. And we have done quite a few here in Germany and also on climate protection. We just, there's a little bit of advertisement here, got the German prize for the best participation project on climate change. Out of 160 entries, we won first prize. By which we take specifically randomly selected citizens from various constituencies, and we did this in one of the states in Germany, and had many communities involved, and asked them, what can your community do to protect the climate? Not what can the world do, what should others do, what can you do? And we got wonderful and very creative ideas, and most of them fund from the state, that the state would fund the best ideas, which they did. And as a fact, I mean, not just because of the program, but there's a really significant reduction of CO2 emissions in the state of Baden-Württemberg over the last 5 years. So to that extent, I think public participation is a way to bridge the gap between the systemic risk on one hand side and the plausibility gap on the other side. Once we have people working on a specific task and a specific mandate, they can overcome the biases that we sometimes see when people just listen to communication. And I think communication is important. We cannot involve everyone, but involvement is crucial. And if we get more involvement programs all over the world, the plausibility gap or the plausibility paradox, then I think we would be much better off in dealing with systemic risks. Because in the long run, the great success that we have experienced in the conventional risk will be phased out when we don't have similar success with dealing with systemic risks. Thank you very much.
That was fantastic, Ortwin. Thank you. And I'm going to remind everybody that they can ask questions by typing their questions into the GoToWebinar control panel questions area. And while people do that, I'm going to stall for a little bit until we start getting questions. By reminding you that all of the webinars that we have are available at sra.org, and you can go there and click on, as long as you're a member, you can click on the webinar tab and then go right and see them and stream any of them. We also have the annual meeting coming up in New Orleans in just a few days, and we hope to see many of you there. Like I said before, it's not too late to join that. And so let's see, we don't have any questions that have populated the question thing yet. That just means that you answered all the questions so far, Ortwin.
Oh, well, but again, I mean, if people have questions later on, I mean, I'm very happy to respond to these questions. I know sometimes you just have to digest all of this, and you can either email me or whatever, send it to Brett or whatever. I'm very happy to give you also written answers. I mean, that's a part of the deal here, that if you feel you have to think a little bit more about it and you want to share some comments or some questions with me anytime.
Okay, that sounds good. And in the meantime, let's give everybody another minute or two to see if there are any written questions that folks want to have. I see there are a lot of people that are still connected on the webinar, and so I don't want to cut people off if they're frantically trying to type a question in. We had a couple of little glitches on the audio, but I don't think they were significant enough to cause any problems with comprehension or with the flow of your presentation. So I was able to follow it without any trouble. So
okay, that's good. Yeah, sometimes, I mean, It's great that we have this technology here that we can do this, from the living room.
Right.
But nevertheless, sometimes it also fails a little bit.
That is true. That is true. Okay, well, it doesn't look like we have any written questions, and so I will also extend the comment from Ortwin that you're welcome to send any questions if you have them to me. You will receive everybody who's attending will receive an email automatically from the system, just saying thank you for having attended. And if you just hit reply to that with any questions, they'll come right to me, and I'll pin down Ortwin, and we'll get the answers to you.
Yeah, I'm very happy to do this and do it quickly. So don't worry, and don't wait a year for giving you the answer.
That's great. Thank you again for doing this, and thank you everybody for attending. And have a wonderful day. Hope to see you in
All
New
right,
Orleans.
thank you all. Yeah.
Bye, everybody.